Hello everybody, in this video we're going to talk about how to solve a right triangle. So first of all, what do we even mean by that? Let's read. To solve a right triangle means to find all unknown side lengths and angle measures. So we're going to be given some kind of information with our problem. We need to find all three sides, or whatever sides we don't know already from the problem, and all three angles, right? Well, one angle we should know should be 90 degrees, right? So we need to have maybe one of the other two angles, but our goal is to find all three of our angles, all three of our side lengths. So we can solve a right triangle when we know one of these two things. Number one, we know at least two side lengths, because if we know two side lengths, we could use the Pythagorean Theorem to find the third, and then we know that we have our 90-degree angle, so then we can use our trig ratios to find the other two angles, so our inverse ratios. Or if we have one side length and one acute angle, then we can solve the right triangle. So if we have one side length and one acute angle, we could use our trig ratios to kind of piece together our missing sides and our missing angles. So we're going to look at one example of each. So for example one, just says solve the right triangle, we're given two side lengths. Okay, so now we're going to start off with a squared plus b squared equals c squared, right? That's our Pythagorean theorem. And we are given one leg and the hypotenuse of this right triangle. So let's just say 24 squared plus b squared equals 25 squared. Okay, so now we can do 24 squared, and that gives us 576, plus b squared equals 25 squared, and that gives us 625. Okay, so now we subtract 576, and we get b squared equals minus 576, 49. And now we can take the square root of both sides. 49 is a perfect square, so we know b is equal to 7. Okay, so that is our missing side right there. So we'll say right here that AB equals 7. Okay, and now we need to find the measure of angle A and the measure of angle C. Okay, we don't need to find the measure of angle B because it has a right angle box, so we know it's 90 degrees. Okay, all right, so now let's pick a trig ratio. Let's start by finding angle A. Okay, so now for angle A, we have options, right? We could use sine, we could use cosine, we can use tangent, the inverse of any one of those three, it does not matter. Okay, so let's just use sine. Okay, so sine is opposite over hypotenuse, right? So opposite over hypotenuse. So to find A, we're going to have to do inverse sine, okay? And we're going to do opposite over hypotenuse. Okay, so in my calculator, I'm going to do second sine, 24 over 25, and that gives me 73.7. Okay, so we'll say 73.7 degrees. 73.7. Okay, now for angle C, we could use a trig ratio, or we could just subtract, because now it's our last angle that we need. So we're going to just do 90 minus 73.7, and we can do that in our calculator, 73.7, and that gives us 16.3 degrees. Okay, so now we have all of our missing information here, so we have solved the right triangle. Okay, so now going back to angle C, if you want to use a trig ratio, that's fine. We use sine for this one, so let's use cosine. So we did sine for angle A, so let's do cosine for C. Cosine for C would be adjacent over hypotenuse. So we would do cosine, inverse cosine of 24 over 25, because adjacent is 24, hypotenuse is 25. So if we do second cosine, 24 over 25, and in our calculator it tells us 16.26. Okay, well we were rounding to the nearest tenth, so 16.26 is the same as 16.3, which is what we got from just subtracting from 90. Okay, so either one of those works, whichever you feel more comfortable with. So this was our example where we knew two side lengths. We found the other side length and the two acute angles. Our last example here, now we only have one side length, but we do have one of the acute angles. So we could go ahead and start solving for the side lengths, but let's just solve for our angle first. So we know that we are missing the measure of angle Y, we are missing side length X, and we are missing side length Y. So for Y, we know that this is 90 degrees, we have 41 degrees. So if all three angles add up to 180, we know we could just do 90 minus 41 to find angle y. So when we do that, this is equal to 90 degrees minus 41 degrees. And we do that, and that's going to give me 49 degrees. Okay? All right, so now we can use, we'll add that in here to our triangle. So we'll write this as 49 degrees. And now we just need to find x and y. And we can use any one of our inverse trig ratios because we know all of our angles. Or not our inverse ratios, just our regular trig ratios because we know the angles already. Okay? So let's do tangent if we can. Let's see, opposite over adjacent. We can't do tangent yet because we need that hypotenuse, right? So I was going to try and do tangent if we could because we've already done sine and cosine. But we only have the hypotenuse of this right triangle, so we have to start off by either using sine or cosine because those deal with the hypotenuse. All right, so let's try to solve for x here. Okay, so if I use my angle 41, I'm going to say the sine of 41 is equal to opposite, so x, over hypotenuse, which is 18.4. So to solve this, we just multiply both sides by 18.4, and we type this in our calculator. So 18.4 times sine of 41, and this gives me 12.1. So we'll round that to the nearest tenth. So 12.1, and we'll add that right here, 12.1. All right, so now let's use cosine, okay? Trying to think if we could use, we still can't use tangent yet because we don't know an adjacent side or we don't know opposite, okay? So let's use cosine now. So we're gonna say cosine of 41 would be adjacent, so y, over hypotenuse, which is 18.4. So now we're gonna multiply both sides by 18.4 again. So now in our calculator, we do 18.4 times the cosine of 41, and that gives me 13.9, okay? So now we have all three of our missing measures. We had measure of angle y, which was 90 minus 41, so we got 49 degrees. And then we used sine and cosine to get the side length of x and the side length of y. So one thing that we can do to kind of check to make sure this makes sense, we know that 49 was our bigger acute angle. So 49 should be opposite the larger side. So y we found was 13.9. And 41 is opposite of 12.1. So that looks good because our smaller side is opposite the smaller angle and our larger leg is opposite the larger angle. Okay, and so that is how you solve right triangles.